So today we are going to learn about basic identities. So in other name, it's called about Pythagorean identities. So Pythagorean identities actually is based on the identity that developed from the Pythagoras Theorem. So Pythagoras Theorem will be involve a right angle triangle, okay, which we have angle A with opposite length as y and adjacent length as x and hypotenuse as r. So in order to calculate your sine A. So sine A will be equal to opposite over hypotenuse, which is y over r. While cos A will be equal to adjacent over hypotenuse, which is x over r. While for tangent A, which is equal to opposite over adjacent, which is y over x. So let's say we want to find cosec A. So cosec A is actually 1 per sine A. So in other words, we have r per y. While for secant A is equal to 1 per cos A, which is r per x. In other words, cotangent A will be equal to 1 per tangent A, which is x per y. So let's say by using Pythagoras Theorem, so we know that for Pythagoras Theorem, r squared will be equal to x squared plus y squared. Okay, so if this equation is divided by x, okay, or we divided by r first, so r squared divided by r squared and x squared divided by r squared and y squared divided by r squared. So each of this will be written in terms of sine cos tangent. So r squared per r squared will be equal to 1. So x squared per r squared is actually x per r squared. So x per r is cos squared. So this x per r is actually cos square A. Now y squared per r squared is actually sine square A, which if you note that x squared per r squared is actually x per r squared, which this x per r is actually cos A squared. So cos A squared can be written as cos square A. So that is why your x squared per r squared will be equal to cos square A, and your y squared per r squared will be sine square A. So r squared per r squared will be equal to 1. So in other words, this can be written as cos square A plus sine square A is equal to 1. So this is your first basic identity. Now, just now from the Pythagoras Theorem, so we have r squared is equal to x squared plus y squared. So if we divide it by x squared, so each term is divided by x squared. So r per x squared, r squared per x squared is actually secant A. So means that we have secant square A is equal to, so x squared per x squared is 1. So y squared per x squared is actually y per x squared, which is tangent A, tangent square A. So this is your second basic identity. So from the same Pythagoras Theorem, we developed the third Pythagoras Theorem, the third basic identities, which is r squared is equal to x squared plus y squared. So each term we divided by y squared. So this r per y will be equal to cosec A. So r squared divided by y squared will be equal to cosec square A. And then x squared per y squared will be equal to x per y squared, which is your cotangent square 8. So this is actually cotangent a squared. So y squared plus y squared is y. So this one is your third basic quantity. So these three basic quantities will help you to prove your trigonometry equations and also solving some of the trigonometry equations. So this is the first, second, and third basic quantities, identities.